Welcome back to the Obby series. In today's episode, we're going to be adding a couple of effects when a player reaches a new stage. So when a player reaches a brand new stage, that stage will actually glow and sort of highlight for a second, and then an arrow will spawn at the next stage that they have to reach, directing the player as to where they should progress to next. In addition to those effects, we also set up the portal models to actually teleport us to the next stage whenever we reach a portal. Now, before we hop into Roblox Studio, the first thing that I'm going to recommend that you do is go down below in the description and follow the imgur link to this arrow icon that I created. It's a very simple arrow icon, and it took me less than a minute to create inside of Photoshop, so it's nothing fancy and it's definitely not copyrighted. You're able to use this wherever you want to in your own work and everything else like that. But with that being said, we are going to use this simple arrow icon in our obby, and because it's only a single icon, I didn't want to include it in my icon pack or anything else like that, which is sort of why I uploaded this to imgur, because it's sort of just a standalone image. Anyway, once you go to this page, you should be able to right click on the image and then click Save Image As, and then save it directly to your computer. And then hopping into Studio, let's go ahead and actually upload that image so that we're able to use it. We'll go to the View tab, we'll go ahead and open up the Asset Manager, we'll go ahead and click Bulk Import, and then we'll select the arrow image, and now we have it uploaded into Roblox Studio. So I'm going to go ahead and close out of the Asset Manager. Now, to begin working on this inside of Studio, the first thing that we're going to do is actually create the Billboard GUI for that arrow image that we just added to our game. So inside of the Starter GUI, we're going to go ahead and create a brand new Billboard GUI. Now, if you're unfamiliar with Billboard GUIs, basically the difference between a Billboard GUI and a screen GUI is that a screen GUI is used for sort of flat GUIs that appear on your screen. So these GUIs do not really appear in any 3D or physical space. But when it comes to Billboard GUIs, these are the GUIs that can actually be used to sort of display images in a 3D space. Now, depending on if you kind of turn your camera around, you might actually be able to see an outline selected when you have the Billboard GUI selected. And in a way, it kind of just demonstrates further what I mean as to this GUI kind of being rendered in the 3D physical game world space. And if that's confusing, don't worry. In a second, you're going to see exactly what I mean. Anyway, the first thing that we want to do is go ahead and rename this GUI to be called Stage Arrow. And then inside of here, we're going to go ahead and create an image label. And now we can actually kind of see that image label appearing over here. Now, what we're going to do to kind of make this a little bit easier to work with is we're going to go ahead and select the Billboard GUI, and then we want to look for the Adorny property. What the Adorny property allows us to do is it basically allows us to attach the Billboard GUI to a specific part. So what I'm going to do is I'm going to go inside of the workspace, I'm going to go into the stages folder, and then I'm going to look at the first stage, and then I'm going to select the checkpoint model, and then I'm going to hit the F key, which will focus our camera on this part. Of course, if the F key doesn't work for you, you can right click, and then the option that you're looking for is the Zoom to option. Anyways, now that we have this selected, what we're going to do is we're going to go back down to the Billboard GUI, we're going to go ahead and select Adorny, and then we'll go back up to here and select the model. Now that we've selected that, if we scroll out a little bit, it might be hard to tell, but now the GUI is actually positioned relative to the checkpoint part. So we can literally see the GUI inside of our game world / 3D like physical space. Now, let's go ahead and start off by modifying the size of the Billboard GUI. That's another thing that makes this a little bit different than the screen GUIs is that Billboard GUIs actually have a size property that we can specify. Now, one key thing when it comes to sizing Billboard GUIs is currently, by default, we can see that it is set in offset. And then if we scroll out or move our camera further away from the GUI, we can actually see the GUI kind of scaling it and increasing in size the further we move away from it. But now what we're going to do is change the size from using offset to actually using scale. So for the size property, we're actually going to use scale, and we're going to set both the X and the Y axis to 10 on their scale portion. And now that we've set the size using scale, when we scroll out, we don't actually see the GUI changing or kind of like resizing as we get further away or closer. Although if we get close enough, we can actually see the image label doing the exact same thing that the Billboard GUI was doing originally. But don't worry about that because we'll go ahead and modify that in just a minute. Anyways, another property that we want to modify on the Billboard GUI is actually the Reset on Spawn property. No matter what GUI it is, we always want to set that to false. Now, we're going to be kind of swapping between modifying the Billboard GUI and modifying the image label here. Generally, I like to modify all of the properties of a single element before going to another one, but I think because the Billboard GUI is a little bit new, handling it this way I think will make it easier to explain all of the individual properties that we're going to modify of the Billboard GUI that we have not worked with in the past. So going back to the image label, we're going to go ahead and rename this to be called Arrow. And then for the image property of this, we're actually going to go ahead and set this to the arrow icon that we've just added. Now, if you actually search for the icon and it shows a different image, but it has the correct name, That is just a studio bug that has been around for quite some time and still isn't fixed. When you select this image, it should actually appear with the image that you're looking for though, and not the image that was displayed when we searched that up. I know, it's a little bit weird, but it's Roblox. I mean, what can you say? Anyways, another property that we're going to modify on this is the background transparency, and we're going to go ahead and set that to 1. Okay, now, as we can see, the arrow is actually appearing as sort of a bluish color, which is a little bit odd because when we downloaded this file, it was actually a white arrow. Now, going back to the Billboard GUI, another property on here that we want to adjust is actually the light influence property. Essentially, the light influence property controls how much the Billboard GUI is influenced by the lighting in the environment. So, because I don't want this to be influenced by light at all, we're going to go ahead and set that to 0. And now once we set that to 0, the arrow image actually now becomes that white arrow, the same color that it originally was. And then one of the final properties that I want to adjust on the Billboard GUI is actually the studs offset. The reason that we're going to adjust this is because we basically want to bring this GUI up a little bit so that it's not on the exact same Y level as the checkpoint that we've set the Adorny property to. So we're going to change the studs offset from 0 over to 15 so that it appears a little bit above the checkpoint. Now, it might be a little bit hard to see, so just adjust your camera angle for however makes it easier for you. But now the next thing that we can see is that depending on where our camera is, along with the Billboard GUI, the image will basically be resized. So what we're going to do is we're going to go ahead and select the image label, and then we're going to actually modify the size property, and we'll be using scale for this. So on both the X and the Y axis, we're going to set that to 1 for the scale portion. And now we can see that it's taking up the entire width and height of the Billboard GUI. And now as we zoom our camera out or move it closer, we can see that the image is no longer being resized, and instead it's actually maintaining its current size. Now, another thing that we can do, but we don't have to, is change the scale type from stretch to fit. I always like to go with fit because depending on the sizing that you're using and depending on the original size of the image that you're using, when you're using stretch, the image can look a little bit bad. But when we use fit, it basically keeps the image at a perfect resolution and doesn't stretch it out and make it look ugly. Now, another cool thing that we can actually do with the image label is we can actually change the image color property. So I specifically made this arrow white in order to make it easy for other people to recolor this. So, if you don't want this arrow to be white, you can simply just modify the image color property and change this to whatever color you'd actually like. Now, I'm actually going to go with a nice little green color, so that's what I'm going to change my image color to, but feel free to change it to whatever you'd like to. Anyways, with all that being said, we're actually finished with creating this GUI, so the last thing that we're going to do is actually reset the Adorny property. So we're going to select the Adorny property, and then we're going to select this red X button that appears next to it, which is the clear value button. And now that we've cleared that out, we can no longer see that arrow. So now we can start getting around to scripting. So to begin scripting, the first thing that we want to do is actually update the GUI controller to add this Billboard GUI to it. So we're going to go inside of the starter player, inside of the starter player scripts, inside of the controllers folder, and then open up the GUI controller. Inside of here, if we scroll down, we can see that we have the GUIs variable, which contains all of our screen GUIs inside of it. And what we're going to do is actually above this variable, we're going to go ahead and create another shared variable, which we're going to call Billboard GUIs. And it's going to be also set to a table. And then inside of this table is where we want to add our brand new Billboard GUI that we just created. So I'm going to go ahead and say stage arrow equals, and then we'll say player GUI, wait for child, and then we'll go ahead and wait for the stage arrow Billboard GUI. And that's actually all that we're going to do inside of the script, so we can go ahead and close out of that. And now the next thing that we're going to do is actually create a brand new controller. So to save us a little bit of time, I'm going to go ahead and duplicate the respawn controller and rename this to be called progress controller. Then I'll go ahead and open this up, and now let's go ahead and update some variables inside of here. So we don't actually need the player service, but we do need the replicated storage. And in addition to that, we also want to create a variable for the tween service as well as the workspace service. Then we no longer need a player variable, but we still do need the state controller. We do need the stages config, and we actually also need another controller as well, which is the GUI controller. So let's go ahead and create a variable for that. We don't need the remotes variable, so we can go ahead and remove that. And now when it comes to the onStart function, we actually do need some of the things inside of here, like we are going to listen to the update state event, but we're not going to need all of the other code inside of here. So I'm actually going to keep this if statement because we are actually going to use the update stage if statement, but we can remove all of the other code inside of the onStart function, and then we can also remove all of the other functions that we created below that, and essentially this is what you should be left with inside of your brand new controller script. Okay, so going back towards the top of the script, let's go ahead and create a variable called GUI, and we're going to set that to the specific Billboard GUI that we just created. So we'll go ahead and say GUI controller.billboardguis.stageArrow. And now what we're going to do is create a brand new function, which is going to be a part of the local table. And we'll go ahead and call this function displayArrow. Now, believe it or not, this function is going to be called every single time the player stage has been updated. So since we already have this entire thing set up, what we can do is we can just go ahead and call this function inside of here already. Cool. So now what we're going to do with this function is every single time the player reaches a brand new stage, we want to calculate their next stage. And then once we've calculated that, we then want to go ahead and display this arrow above that checkpoint and then use the tween service to do a little animation, making the arrow move up and down and indicate to the player that this is the next checkpoint that they should be going for. So let's go ahead and create a variable called next stage. And now to get the player's next stage, we're going to go ahead and use the state controller. Then we'll go ahead and get their state, and then we'll go ahead and get their current stage, and then just add 1 to that. Then we want to go ahead and get the spawn location of that stage. And we can do this by using the stages config. So we'll say stages config.get spawn location and pass through the next stage. Now, of course, if we don't get a spawn location, then we want to go ahead and return n to stop the function right there. But now that we know that we've gotten the spawn location, what we're then going to do is actually set the adornee property of the Billboard GUI to that spawn location. So now the Billboard GUI is appearing at the spawn location. And now what we'll do is write out the logic for the tween effect. So we're going to create a variable called tweenInfo, and to create the tweenInfo, we need to say tweenInfo.new. And now, how long do we want this animation to take? Well, I'm going to say 0.5, so that it takes about 3/4 of an entire second. Then for the easing style, I'm going to say enum.easingStyle, and then we're going to use the quad easing style. And then for the easing direction, what we want to use is in out. And now the next argument that we're going to pass through is how many times this tween should repeat. And now since the animation that we're creating is sort of an effect which makes the arrow go up and down, we're going to go ahead and actually use the repeat count argument here in order to easily make that animation. So we'll go ahead and pass through 5 so that this animation repeats 5 times. And then for the last argument, we're going to pass through true because this argument is called reverses. And when we pass through true, that's making the tween actually go backwards every single time that it's ran. So with our tween, we'll actually make it go down. And then because we pass through true for this argument, that'll make the tween actually reverse. So it'll automatically handle reversing, and then it'll also automatically handle repeating itself as well. And that's all that we're going to do for the tween info. Then we're going to go ahead and create another variable, which is called tween props, and we're just going to set that to a blank table. Then we'll go ahead and use the table, and then we're going to add a property to it, which is going to be called studs offset. And you should be familiar with the studs offset property because that's the property that we modified on the Billboard GUI to make the Billboard GUI appear above the actual checkpoint. But now when we're using it in this context, we actually want to set the value to how low we want the arrow to go for this animation. Now for this property, we need to use a vector3. So we're going to say vector3.new, and all we're going to set is actually the y-axis. And currently it is set at 15. So we're going to reduce that by about half in order to bring it down a little bit. So we're going to go ahead and set this to 7.5. And now that'll make the arrow go down a little bit. Now that we've created that table, let's go ahead and actually create the tween itself. So we'll say tween service :create. Then we'll pass through the Billboard GUI as the instance that we want to tween. Then we'll pass through the tween info. And finally, we'll pass through the tween props. Now that we've created that tween, let's go ahead and actually play it. So we'll say tween and then :play. And now there's one more thing that we need to do inside of this function, and that is listen for when the tween has completed. So we'll say tween completed, :connect, and then create an anonymous function inside of here. And we're doing this because once the tween has completed, we actually want to reset the adornee property of the GUI. And we're actually going to set that to nil so that it is not adorned to any part. Because if we forget to reset this property, then essentially the arrow will always stay above the same checkpoint until this function is called again, and then it'll move to the next one. Now with that being said, that's actually all the logic that we need to write for displaying this arrow. So we can go into our game and start this up to test it out. So once we get into our game, I'm going to go ahead and reach the next stage. And once I reach the next stage, we can actually see the arrow appearing towards the next one that I'm supposed to go to, and it's also being animated. And that's looking pretty good. So once I reach the next one, we can see it moves to the next checkpoint, and it continues to direct me to the next checkpoint that I'm supposed to move to. So that seems to be working perfectly. Now, one more little thing that we can do to actually improve this is we can actually call this function not only when the player's stage changes, but also when the player joins the game for the first time as well. So let's also go ahead and call this function down here inside of the onStart function, so that just in case maybe the player joins our game back and they forgot which way to go, this will at least direct them in the right direction. Turns out that the way that we've set up the arrow effect is actually a little bit flawed. It might be a little bit hard to see this, but if you are using skips, it makes it a little bit easier to see it. So basically, let's go ahead and reach the next checkpoint, and then we do see the arrow has appeared. But actually, we can see the issue right here, and it just seems like sometimes, occasionally, the arrow does not actually tween, and the tween kind of breaks. We can even see the arrow appearing over here as well, and the issue is still present. But we can actually kind of see it moving a little bit. It actually looks like it's like literally lagging. So let's go ahead and fix this. Now keep in mind that when I am fixing this, what you're seeing on screen right now is recorded after I fully finish this entire episode. So rather than inserting this part at the very end of the video, I figured it would be a little bit more helpful and made a little bit more sense to insert this after we've actually finished scripting in the arrow effect itself. So if your script looks completely different than mine, that's because we haven't actually gotten to the part yet where we implement the highlight part effect and different things like that. But don't feel too overwhelmed or anything like that. Our display arrow function is completely the same, and then everything else that we've done before that is also identical as well. Now, taking a look at the display arrow function, the way that we currently handle this tween is every single time the display arrow function is called, a brand new tween is actually created. And then we use that tween on the Billboard GUI and modify the studs offset property. And once that tween is completed, we then go ahead and set the adorning property to nil so that it's no longer displayed above that part. Now, I have tried a couple of different ways of solving this issue. Some of those involve canceling or pausing the tween, because that is a literal method, so you can pause or you can cancel the tween. And also, pausing it in this context doesn't actually matter because we create a brand new tween every single time. Essentially, what I did try to do is actually take like all of these variables, or well, really all of these variables, and put them outside of this function. So I would like put them up here, for example, and then I tried pausing or canceling the tween, but that actually didn't solve this at all. And I've tried a couple of other things that just did not actually solve this issue. With that being said though, there is actually a pretty easy solution to solving this. Instead of handling it this way, what we're actually going to do is clone the GUI every single time that we call this function. And since we're basically creating the GUI every single time that we're calling this function, we're going to tween that individual GUI. And when we handle it that way, it's very simple, and it also just kind of solves all of the issues that we're facing right now. So before we update this function, what we want to do is go towards the top of our script, and between the onStart function and our local and shared variables, what we're going to do is create a local variable, and we're going to call this active GUI. And by default, we're going to go ahead and set that to nil. Then let's scroll back down to the display arrow function. And now what we want to do after we determine that we have gotten a spawn location, we want to check if there is an active GUI or if that variable is actually set. Now for the value of active GUI, we're going to set the value to the brand new GUI that we're going to clone every single time we call this function. So when this function is called, if there is an active GUI, then what we want to do is destroy that active GUI. So we're going to go ahead and say local.activeGUI, and then we'll go ahead and call the destroy method on that. And now after that, rather than using the adorning property, we're actually going to clone the GUI entirely. So let's go ahead and remove that, and then we'll go ahead and create a variable called clone. And like I said, we're going to go ahead and clone the GUI. Now that we've cloned it, we need to make sure that we parent it to somewhere. And instead of even using the adorning property, what we're going to do is actually parent it to the spawn location part. So we're going to say clone.parent equals, and then we'll go ahead and parent it to the spawn location. Now that we've cloned and then parented it, let's go ahead and set this as the value to the active GUI variable. So we'll go ahead and say local.activeGUI, and then set that to the brand new clone. Next, we want to make sure that we update our tween a little bit, because currently it is using the GUI, but instead we'd like to tween the clone. Then we play it as usual. And then once the tween is completed, rather than adjusting the adorning property of the GUI, what we're instead going to do is actually destroy the clone. And now with that being said, we should be able to hop into our game and test this out and see that the issues have actually been fixed. So once we get into our game, we can see the arrow right there. Let's go ahead and use a skip. We can see the arrow going forward as well, and that's continuing to tween as it normally would. We'll skip again, and we can see that that's working correctly as well. So this seems to solve our issue, and now it seems to be working perfectly. Now with that being said, remember how I said this fix was recorded after the entire video has been finished. So the next couple of of seconds that you're going to see will probably have the display arrow function looking how it was before we implemented this fix. So don't let yourself get confused by that, because again, this was recorded afterwards, and this is exactly what your script and your logic should actually look like. Now that we've implemented displaying the arrow above the next checkpoint, the next feature that we're going to implement is highlighting the checkpoint part that the player has just reached every time they reach a brand new checkpoint. Now, before we do this, what we should do is actually take a look at how the checkpoint parts are set up inside of our workspace. So I'm just going to go towards one of our first checkpoints, and then I'm going to go ahead and click on it. Now, if you're unable to actually select this checkpoint, then what I would recommend you do is just go through the workspace, go through the stages folder, select one of the folders, and then select the checkpoint model that way. Anyways, once you have the model actually selected, let's go ahead and look inside of it. Inside of the model, there are 3 different parts. The first part is called arrow, which is literally just the arrow part inside of it. Then we have the border part, which is actually this red part surrounding it, so I can move this a little bit to make it easier to understand and see. And then the third and final part that we have is called inside, and that is the actual filler or inside part of our checkpoint. Now, once again, if we select the model, we can actually see that the model has the primary part property set, and this is set to the inside part. Now, the entire setup doesn't exactly matter. My entire point with this, though, is that we actually have to do something because, unfortunately, I didn't realize that I didn't actually keep the naming scheme the exact same way for every single checkpoint. So if we look at stage 10, for example, and if we look at this checkpoint, everything about it is exactly the same as the first checkpoint, but the only difference is that the border part is not named border, and it's actually named inside, so there's 2 parts inside of our checkpoint which are both called inside. So what we want to do is we actually want to rename all of the parts which are supposed to be called border but are instead called inside. Now, we have a couple of options of how we could go about this. Of course, we can manually rename them by hand, but there's actually a pretty simple little script that we could write to handle this for us. Now, keep in mind that the key difference here and the way that we're able to actually do this is because if we take a look at the brick color, that is sort of the outlying factor here. If we look back at the first checkpoint, for example, we can see that where this is set up correctly, the inside part's brick color is actually hurricane gray. But then if we go back to the one that was set up incorrectly, we can see that one of the inside parts inside of here also has the brick color of hurricane gray as well. So what we're going to do is write a very short script that basically loops through all of the descendants in the workspace, and then to easily differentiate the correct inside part from the incorrect inside part, we're actually going to use the brick color and then rename the opposite one, which does not have the brick color of hurricane gray. And if that's confusing at all to you, don't worry. You should have an easy time following along with this, and it should be very simple. Now, we're actually going to run this little script inside of our command bar. We're not actually going to make a literal script for this, but we are going to kind of write the script out inside of here. It might sound a little bit confusing, but basically we're just going to kind of use the progress controller script as a whiteboard that we're going to write this script inside of. Then we'll go ahead and copy all of that, paste it in the command bar, run that command, and then we'll of course remove all of the code from both the command bar and then inside of here as well. The reason that we're writing it inside of here is because if we were to write it inside of the command bar, it is significantly harder to write it inside of the command bar because it's just a very small, tiny bar that you can write it in. So that's why we're writing it inside of the script to start off with. So with all that being said, what we're going to do is we are going to iterate through all of the descendants inside of the workspace. So we're going to say game.workspace. And the reason we're doing that is so that we don't have to create a variable for the workspace service. We can easily just access it through the game global. And then we're going to go ahead and use get descendants on it because we want to iterate through all the descendants in the workspace. Then what we're going to do is create a variable called isInCheckpoint. So the first thing that we want to do is make sure that the part that we're working with or that we're modifying is actually inside of the checkpoint model. So to determine this, we're going to say descendant.parent.name. And now if the name of the parent of this descendant is checkpoint, then we know that we're working with one of the parts inside of the checkpoint. Then we're going to create a variable called isMeshPart. And all we're simply going to say is descendants is-a, and then we'll check if it is a mesh part. Now also, I should have called this descendant and not descendant, so I'm going to go ahead and just rename that variable, even though it literally doesn't matter at all. Honestly, I didn't need to do that. But anyway, the last variable that we want to create inside of here is called isInside, because we want to make sure that the part that we're working with is actually one of the parts named inside. And we can determine that by checking if the name equals inside. Then we'll go ahead and create an if statement. So if the descendant is in the checkpoint model and it is a mesh part and it is inside, meaning that it is an inside part, then what we're going to do is we're going to first check if the brick color of the descendant does not equal, and then we're going to say brick color dot new, and we're going to check if it does not equal hurricane gray. Because if it is not hurricane gray, then we know that we've got the opposite part or the not inside part. So then what we're going to do is actually set the name of this descendant, and we're going to go ahead and set it to border. Cool. So now that we've written all that out, let's go ahead and highlight all this code, copy it by hitting Control C, and then we can even just delete it from the script if we want to. Then we'll go back to looking at our workspace. And now to enable the command bar, there's a couple of ways to do this. You could go to the View tab and then toggle on the command bar from here. You could also just right-click inside of the studio, and then you can enable command bar all the way at the bottom down here as well. But anyway, once you have the command bar enabled, where it says run a command, go ahead and paste all of your code inside of there, and then hit the enter key. Once you've hit the enter key, you should actually see some mesh parts renamed from inside to border, and now you should no longer see two inside parts inside of a checkpoint. Just to confirm that this did actually work, we'll go ahead and search for inside, and when we do that and we scroll through this, we can see that there's only one part named inside of every single checkpoint. So now we know that we have updated all of the checkpoints correctly. Cool. So now that we've done that, let's get back to our script, and now we can actually implement highlighting the part once the player has reached a brand new checkpoint. So in order to do this, above the display arrow function, we're going to go ahead and create another function, which again is going to be a part of the local table, and we're going to go ahead and call this function highlight part. Now this function is going to have a single parameter, which is actually going to be the stage, which is a number. So because we're given the stage that we actually want to highlight, what we first want to do is get the folder of the stage. So we'll go ahead and create a variable called folder. Then we'll go inside of the workspace, inside of the stages folder, and then we'll go ahead and index the stages folder with the specific stage that we're looking for. Now that we've gotten that stage, let's go ahead and get the checkpoint model that's inside of that folder. Now, because we have streaming enabled, we do want to be a little bit cautious about how we go about getting this. So we're going to go ahead and create a variable called checkpoint. And to get the checkpoint, we want to go ahead and use wait for child on the folder. And we want to wait for a child called checkpoint. And because streaming is enabled, we're going to go ahead and wait 10 seconds at max in case checkpoint is not found. Additionally, if we want to, we can assert the type of the checkpoint variable to actually be a model, and that makes it a little bit easier to work with. Now, after we've created that variable, if we do not get a checkpoint, then we do want to make sure that we stop the function right there. After that, we want to go ahead and create a variable for the inside part, and we can assert the type of this to actually be a part. Now, to get the inside part of our checkpoint, of course, we're going to go ahead and use the checkpoint. Then again, we'll use wait for child just because we have streaming enabled, and just because a model was given to us, that doesn't mean that all the children of that model have been streamed in at the exact same time as well. So that's why we're being cautious by using wait for child. Now, the child that we want to wait for is called inside, and in the worst case scenario, we want to wait 10 seconds for that as well. And considering we're waiting for a child named inside, you should now have a better understanding of why we actually went through that process of renaming all of those parts which were originally named inside when they should have been named border. Anyways, if we're not able to find the inside part, then we're going to go ahead and stop the function right there as well. But now that we've gotten the inside part, let's go ahead and start writing the logic for the tween. So we're going to go ahead and create our tween info variable. Then we'll go ahead and create the tween info. So we'll say tween info.new. How long do we want this tween to take? I'd say about 1 second. For our easing style, we'll go ahead and use quad. Then for our easing direction, we'll go ahead and use in out. Now, we don't actually want this to repeat, so we're going to go ahead and pass through 0, but we do want this to actually reverse. Because effectively what we're going to do is sort of make the part glow for a second, and then we want to reverse that effect and just revert it to what it originally was. So that's why we're going to pass through true to here as well. Now that we've created the tween info, let's go ahead and create our tween props table, which of course is going to be a blank table. Now for the tween props, the property that we actually want to modify is the color property. And we can modify that by using a color3.fromRGB. And the color that I'm going to go with is 0255, 0, and that is a nice bright green. And now that we've ran all of that information, let's go ahead and actually create the tween itself. So we'll go ahead and use the tween service. We'll use the create method. Now, what do we want to tween? Well, we want to go ahead and tween the inside part. Then we'll pass through the tween info and the tween props as well. Now that we've created that tween, let's go ahead and play it. And now another thing that we're going to do to make this effect look even nicer is we're actually going to change the material of it as well. And since we're changing the material, we are going to want to revert it back to the original material. So let's go ahead and create a variable for to store the original material. And to get the original material, we're simply going to say inside part.material. Now we're going to go ahead and change the material. So we'll go ahead and say inside part.material. And then to set the material, we'll say enum.material. And the material that we want to set it to is actually neon. The reason that we're setting it to neon is because this material actually allows the part to give off a very nice glow effect. And now the last thing that we need to do is revert the material change as well. And we can go ahead and do that by listening to the tween being completed. And then once it has been completed, we'll go ahead and change the material of the inside part back to what it originally was. So we'll go ahead and use the original material variable just like that. Okay, and now that we've created this entire function, let's go ahead and use it. And we're also going to use it inside of the onStart function when the player stage has been updated as well. But what we actually need to do is update this function a little bit because we need to include the second parameter, which is actually the state, and that is of the state controller.playerDataType. And the reason reason that we need the player state is because when we call the highlight part function, we want to go ahead and pass through the stage that the player is currently on, just like that. Cool. And now that we've done that, we can go into our game and test this out as well. So now that we're in the game, I've reached the next checkpoint, and we can see that that actually glows a little bit once I've reached it. Now we'll go ahead and go to another checkpoint, and we can see that animation plays once again, then it reverts back to its original material and its original color, and it looks very nice. So we can clearly see that that nice little tween effect is working exactly as it should be. Cool. So now that we can see that that's working exactly as we wanted to, we can go ahead and close out of the progress controller because we're done with modifying that. Now the next thing that we want to do is write the logic for making the portals work. And to do this, we're going to begin by writing this logic on the server side. So we're going to go inside of the server script service, inside of the services folder, and we want to actually go ahead and update the progress service. So let's go ahead and open up that module script. Now inside of here, towards the top of our script, we first want to go ahead and create a variable for the replicated storage. In addition to creating a variable for the replicated storage, we also want to create two other variables. The first variable that we want to create is a variable for the respawn service, which of course we get through the server script service, .services.respawn service. Make sure you get the respawn service and not the rebirth service. Very easy mistake to make. And then one more thing that we want to get is actually the stages config. So we can go ahead and get that from inside of the replicated storage, inside of the configs folder, and of course it is called stages. Now we've gone all of those, let's scroll down in the script a little bit, and below the touch checkpoint function, we're going to go ahead and create another function, which we're actually going to add this to the local table, and we're going to go ahead and call this touch portal. And we're going to actually set this up pretty similar to the touch checkpoint function, so I'm going to copy the parameters and paste them inside of here. For the second parameter though, instead of checkpoint, we're actually going to go ahead and get the portal, and the type of the portal would actually be a mesh part because it's actually going to be that inside part of the portal model. Now, whenever the player touches a portal, what we need to do is actually check what stage they're currently on. So to do that, we first need to go ahead and get the player state. So we'll go ahead and do that by using the player data service. We'll go ahead and get their state, pass through the player. Now, if we're unable to get their state, of course, we'll go ahead and return n and stop the function right there. Then we'll go ahead and create a variable for the player's stage. And we can get that from their state. So we'll go ahead and say state.stage. Now we've gotten the stage that they're currently at, we want to make sure that they're actually at a stage where a portal belongs. So we'll create a variable called isAtPortalStage. And because of how our Obby is set up, we have a portal placed every 25 stages. So at stage 25, at stage 50, 75, and 100, there will be a portal that players can use at each of them. Of course, if you have your Obby set up differently, then you're going to have to write the logic for this function a little bit differently as well. But I would recommend, to make it easier on yourself, include your portals in a consistent manner. So maybe every 10 stages, maybe every 15 stages, maybe every 20 or 25 stages. Doing something like that will allow you to not really have to change most of the logic that we're writing here. But if you do it a little bit differently, then you are going to have to modify this logic. I mean, at the end of the day, even if you had to, you could literally write like player stage equals 20 or player stage equals 25. You could do something like this if you really wanted to. Of course, you could also just make a table, and then inside of that table, you write the number for every single stage which has a portal, or do anything else like that. That's all perfectly fine. Whatever method you want to use for handling that, you can figure that out. But on our end, what we're going to do is we're going to go ahead and use the player stage variable, and then we're going to use the modular operator, which is a percent sign, and then we're going to use the number 25. Now, I think we've gone over this symbol before, but basically what this does is it gives us the remainder of player stage divided by 25. Now, keep in mind, my education level when it comes to math is very low, and I also don't use this a lot at all. This might be one of the 5 times I've ever used the modular operator or this form of math ever while even scripting in my last couple of years while developing. Now, I don't know the best way to explain this to you and help you understand, so I'm just going to give you some examples of different results when using this operator. So let's say that the player is currently at stage 24, and then we use the modular operator. Basically, this would equal 24. Now, if the player was on stage 25, though, this would actually be 0. Then let's say that the player was on stage 49, this would actually be 24 once again. But now let's say that the player was on stage 50, that would actually make this number 0 once again. And then for 75, this number would be 0, but if it was 74, then it would be 24. And we could do that for any multiple of 25. But anyway, with that kind of bad explanation out of the way, sorry about that. In addition to just writing out that expression, what we then want to do is check if that number equals 0. Because if that expression equates to 0, then we know that the player is actually at a portal stage. Now, if the player is not at a portal stage, then then we want to go ahead and return N and stop the function right there because we don't have to care about the player touching a portal if they're not at a stage with a portal. Then we'll go ahead and create a variable called portal number because all that's been passed to us is actually the mesh part of the portal. Now to get the number of the portal, we're going to go ahead and say toNumber, then we'll use the portal, but then we actually want to get its parent, and then we're going to go ahead and use the name of the parent of the portal part. Now that we've gotten the portal number, let's go ahead and actually determine what the next stage would be. And to determine the next stage, what we're going to do is we're actually going to multiply the portal number by 25. And then we'll go ahead and add 1 to that. The reason that we're doing this is because how our portals are named, they're named 1, 2, 3, and 4. So that's why we have to multiply the portal number by 25 to be able to determine what the next stage is from that portal. And now that we've gone to the next stage, the next thing we want to do is actually check if the player can rebirth. To determine if the player can rebirth, what we would do is check if the next stage is greater than the total amount of stages. So we can get the total amount of stages by using the stages config, and then we'll go ahead and use the getTotalStages function. And we're doing this because if the player can rebirth, then we want to stop the function right here. So we're going to say if can rebirth, then return end. And the reason that we're doing that is because we're trying to avoid teleporting the player to a non-existent stage because they've reached the end of our game if they're able to rebirth. But now that we've made it this far down, we know that we actually want to teleport the player to the next checkpoint. So what we're going to do is create a variable called spawn location, and we're going to go ahead and get the spawn location for the next checkpoint. To do this, we'll go ahead and use a stages config, then we'll use the get spawn location function, and we'll go ahead and pass through the next stage variable. If we don't get the spawn location, then we're going to go ahead and stop the function right there. But if we do get that function, then what we're going to do is actually use the touch checkpoint function that we already have up here. So we're going to say shared.touch checkpoint. We'll go ahead and pass through the player, and then we'll go ahead and pass through the spawn location as well. And we'll do that in order to act as if the player has touched the next checkpoint, which will forcefully update their stage. And then we want to go ahead and use the respawn service to respawn the player and teleport the player to that brand new stage from the portal. And with that being said, that's all that we're going to do inside of this function. Now, where are we going to use it? Well, we're going to go back towards the top of the script, and actually inside of the setup spawn locations function, we're already iterating through all of the descendants of the stages folder. To make this a little bit easier for us though, and to be able to kind of make our code a little bit I don't know if you'd really call this cleaner, it actually might be less organized, but what we're going to do is we're going to change this from iterating through just the stages folder to just all of the descendants of the workspace. And that's perfectly fine because this function only runs one time when the game first starts up. So iterating through more descendants is perfectly fine. And because of how our Obby's set up, it's not like these spawn locations are existing anywhere else except for inside of each individual stage. So now that we've updated that part, outside of the if statement for checking if the descendant is a spawn location, we'll go ahead and make another if statement, and this time we'll check if the descendant is a model. And we also want to make sure that the descendant's name is portal as well, to know that we're actually working with the portal model. Now that we know that we're working with the portal model, let's go ahead and use that descendant, and we'll go ahead and use the primary part of that model. Then we'll go ahead and listen for that to be touched, and we'll connect that to an anonymous function. For the argument of this anonymous function, of course, it's going to be other part, which is of the base part type. And honestly, we're going to literally do the exact same thing that we did up here. So let's just go ahead and copy and paste this code directly inside of there. But now instead of calling the touch checkpoint function, we actually want to go ahead and call the local touch portal function, passing through the player and passing through the descendant.primary part, which is that mesh part. And since we've updated this function, let's also update the name of this. Instead of calling this setup spawn locations, I'm just going to go ahead and call this setup parts. And since we've renamed it, let's also update the function call inside of onStart, just like that. And with that being said, we're finished with scripting this on the server side at least, so we can go ahead and close out of that script. Now I say that we're finished with this on the server side because we are also going to do this on the client side as well. Usually when we're scripting these things on the server side, the only reason that we're doing it on both the server and the client is because we're using streaming enabled. And if we were to write all the logic on the client side, there is a chance that this sort of malfunctions or things go wrong because a part hasn't been streamed in yet or something like that. And that's where writing some of this stuff on the server side comes in handy as a little bit of a backup to make sure that things are running smoothly, even if things kind of mess up on the client side. Anyway, since we're finished with this on the server side, we can go ahead and collapse the server script service. And now what we're going to do is we're going to go back inside of the start player, inside of the start player scripts, inside of the controllers folder, and instead of updating the progress controller, we're actually going to go ahead and update the effects controller. The reason that we're we're adding it to the effects controller is because a lot of the things that we're doing for setting up the portal is very similar to what we do when we set up a part. So that's why I felt like it fits pretty well inside of the effects controller. Now, inside of the effects controller, the first thing that we actually want to do is towards the top of the script, and we want to go ahead and add a variable for the GUI controller. In addition to the GUI controller, we also want to create a variable for the stages config as well, just like that. And now that we've done that, let's go ahead and go all the way down towards the very bottom of the script, and we're going to go ahead and create a local function, which is going to be called setupPortal. Now, this function is going to have a single parameter, which is going to be called instance, and that's of course of the instance type. And like I said, when we're creating this function, it's going to be created very similar to the setupPart function. So the first thing we want to do inside of this function is make sure that it is actually a portal. To determine if it is a portal or not, what we want to do is we would make sure that the instance is a model and that the name of the instance is portal. Now, of course, if it is not a portal, then we'll go ahead and stop the function right there. Now that we've gotten the portal part, the next thing we want to do is get the inside part, because the inside part is the part that we want to listen for the player to actually touch in order for them to trigger the portal to actually teleport them to the next stage. So we'll go ahead and create a variable called inside part, which we'll go ahead and use the instance, and we want to use wait for child, again, because of streaming, and we want to make sure that we wait for the part called inside to be loaded as well. And we're going to wait a maximum of 10 seconds. Now, if the inside part is not found, then we're going to go ahead and stop the function right there. But now that we've actually gotten the inside part, we can go ahead and listen for that to be touched, and then go ahead and connect that to an anonymous function, with the only parameter being the other part, which is of course of the part type. Or I guess technically we should say base part here, but it doesn't really matter. Anyways, let's go ahead and look at the setup part function. We can go ahead and steal this first little part right here. So we're just going to make sure that it is actually the local player, and we'll go ahead and paste that inside of here. Now that we've made sure that it is actually our client touching this, we kind of have to go through some of the same logic that we wrote on the server side. So we want to go ahead and get the number of this portal. We can do that by saying toNumber instance.parent.name. So instance.parent will take us to the folder which the portal model is stored inside of, and then we'll go ahead and get the name of that folder, which is a number, but technically all names are strings, so that's why we need to use toNumber on it. Anyways, we'll then go ahead and create a variable for the next stage. Now, to get the next stage, what we would do is we would multiply the portal number by 25, and then we would go ahead and add 1 to that. Again, because of how our portals are set up, we're able to use the number 25, but if you set your portals up a little bit differently, then you of course need to make your modifications right here as well. And now that we've gotten the next stage, we're going to go ahead and check if the player can rebirth. To determine if the player can rebirth, we're going to go ahead and check if the next stage is, of course, greater than the total amount of stages, so we'll go ahead and use the stages config.getTotalStages. Now, if the player actually can rebirth, then what we're going to want to do is use the GUI controller, because we want to toggle the rebirth GUI. So we'll go ahead and use the toggle GUI function, and then we'll go ahead and pass through the rebirth screen GUI, just like that. Additionally, we want to go ahead and include return right here to stop the function here as well, because if the player can rebirth, then we don't need to teleport them to another checkpoint. We're just going to go ahead and pop up the rebirth menu and then stop the function right there. But now if we made it this far down, then we know that we actually do want to teleport the player to the next checkpoint. So let's go ahead and do that. We'll go ahead and create a variable for the player's character. So we'll go ahead and say player.character. And if we don't get the character, then we're going to go ahead and stop the function right there. But now let's go ahead and get the spawn location for the next checkpoint. We can do that by using the stages config.getSpawnLocation, and then we'll go ahead and pass through the next stage. Then, as long as we do get the spawn location, what are we going to do? Well, we're going to go ahead and pivot the character to the spawn location.cframe. So we'll go ahead and teleport the character over to the new spawn location. And with that being said, we're actually finished with creating this function, so let's go ahead and use it. And now, where are we going to use it at? Well, of course, inside of the onStart function. Let's go ahead and copy and paste this line here, because instead of just connecting the setupPart function to the descendant added event of the workspace, we also want to connect the setupPortal function to that as well. Then inside of the for loop where we iterate through all of the descendants, we're also going to call the setupPortal function for each of those descendants as well. And of course, we're using descendant added to work with streaming enabled. And of course, this first for loop is actually for when the game starts up for the first time and getting all of the initial portals and parts. But with all that being said, we're now fully finished with implementing this as well, so we can go back to our game and test this out. So hopping into our game, what we're going to want to do is get all the way to the very last stage. So I got to stage 25. Now let's make our way over to this portal. And now let's go ahead and touch this portal. And of course, I made a slight mistake. So let's go back to the progress service. We'll go back to the touch portal function. And the issue here is that realistically, we probably should have called this part inside instead of portal to make it a little bit easier to understand. So when we go to the parent of inside, that actually gives us the model. So then we would have to say .parent once again, and that gives us the actual folder, which is named the number of the specific portal. So with that being said, we can go ahead and test this out once again. And now once we reach this portal and touch the portal, and we can see that we have been teleported to the next stage. So that does seem to be working exactly as it should. With that being said though, we can see an error in the console, and the error is actually not a big deal, but we can pretty easily fix this. So what we want to do is actually go to the stages config inside of the replicated storage inside of the configs folder. So we'll go ahead and open up this module script. And now what we want to do is actually update the get spawn location function. What we're going to do is first create a variable called total stages. And we'll just use that function that we created right above this. So we'll say shared.getTotalStages. And then we'll go ahead and create a variable called isInBounds. And what we're going to do is we're going to check if the stage is greater than 0 and if the stage is less than or equal to total stages. And now if it is not in bounds, then what we're going to do is return end and stop the function right there. So now this will prevent any errors in case the stage passed to this function is greater than the total amount of stages that we have or less than 1, which is our first stage. And now just to make sure that does actually handle this correctly, I'm going to go ahead and test the portal out once again. We can see that once I test the portal out, I'm teleported to the next stage. There is no error, and we can even see that the rebirth menu has popped up for me because I've reached the final stage and I'm now able to actually rebirth. Cool, so that all seems to be working exactly as it should be.